I'm ashamed by the lies and the worthless games, but the wine.
In this first experiment, we'll be mixing about 40 milliliters of nail polish remover, which contains acetone, with some blue glitter. The dye from the blue glitter is able to dissolve and color the acetone pretty well.
I can see you in my bed. I can see you doing all those things we used to do instead. All the fights at 2 a.m. when you knew I was your man. The only thing I'm thinking about, I really gotta hold on.
After making sure this glitter and acetone is mixed together, we're going to be dyeing for about 30 milliliters of water with some yellow food coloring. What's good about the yellow food coloring is that it doesn't dissolve well in acetone like it does in water. Now that we have our two separate substances, we're going to mix them together in a clear plastic bottle. The water and acetone molecules are able to mix because of hydrogen bonding that's occurring. This means there's a pretty strong interaction occurring between the two substances. Here you can see the mixture, which is a pretty ugly brown color. To create the separation of color, we have to add about 10 grams of salt to the mixture. By doing this, the dissolved sodium and dissolved chloride ions are going to strongly interact with the water molecules through ion dipole forces. These ion dipole interactions between the water molecules and ions are so strong that they're going to stick together and actually pull away from the acetone. Fully mixing the solution ensures that the acetone is pulled out.
I can see you in my head. I can see you in my bed.
You can see the two substances beginning to separate here by color.
When you knew I was your man, the only thing I'm thinking about, I really gotta hold on.
This first demonstration shows how hydrogen bonding and ion dipole interactions work.
I really gotta hold on you.
A second demonstration shows how varying intermolecular forces of different substances affect their ability to form the bubble which appears when they are placed on top of a penny. First substance we examined was water. Hydrogen bonds are formed by the hydrogen atoms of one water molecule being attracted to the oxygen atoms of another water molecule. These cohesion and surface tension abilities of the water become apparent as the drops of water begin to reach the penny's edge. The penny was able to hold 46 drops of water before the bubble broke, indicating the strength of these intermolecular forces. The second substance we examined was nail polish remover, which contains acetone. The intermolecular forces and surface tension abilities of this substance are not as strong as those of water, as it was only able to hold 35 drops before the bubble broke. The last substance this demonstration examined was vegetable oil. The vegetable oil is very viscous and does not demonstrate strong intermolecular forces when interacting with the penny. For this reason, the penny was only able to hold 23 drops of oil. In this next demo, a shot glass was completely filled with water, and we asked the question, how many paper clips can we put into the glass before the water overflows? As more and more paper clips were added, it became apparent that the surface was bowing, so that the water was actually above the rim of the glass. The surface tension holds these molecules together and pulls them toward the body of the liquid water. I only stopped when 84 paper clips had been added in total. Because the surface tension is so high, a flag paperclip was gently placed on the water's surface, demonstrating the strength of these intermolecular forces and surface tension. In this demo, we were once again using a clear water bottle to demonstrate the variance in intermolecular properties of different substances.
Stay awake for too long, don't go to bed. I'll make a cup of coffee for your head. I'll get you up and going out of bed. And don't stay awake for too long.
In the end, these substances remained completely separated from one another, despite remaining in the same environment. This demonstrates how the varying intermolecular properties and molecule interactions kept them apart. Lastly, the variance in appearance of different substances when placed on the same surface demonstrates their attractive forces. This demonstration involved placing different substances as two streaks on the same surface. The first substance was water.
Fall back to sleep, please. For a second, for a minute, can we go? For a second, for a minute, can we go?
The second substance observed was oil.
For a second, for a minute, can we go? Can we go back when we were young and didn't care if we messed up? We have forever so.
The third substance was nail polish remover containing acetone.
Wasn't catching, time wasn't catching. Back when we were young and didn't care if we messed up.
After placing each substance as two streaks on the surface, it was noted that they did not look the same.
Time wasn't catching, time wasn't catching up.
Note that acetone's weak intermolecular forces allowed it to evaporate more quickly, while water's more beaded appearance indicates an imbalance of these forces between the other water molecules and the surface itself. This beading is the result of surface tension.
Silver and gold with all our arms.
That concludes my intermolecular forces experimentation at home. Thanks for watching!